Hello guys, and welcome back to another part in my DIY synthesizer basics tutorial. Now in this video what I'm going to show you is how we send all our wave shapes from our oscillator pre our next stage, which would which would be the filter. So what we have here is our, if we look over here, is our operational amplifier, and we can see all the pin out diagram on it. Now if we observe, we have 3 pins which are output pins. One will give us the pulse out, one will give us the triangle, and one will give us the sawtooth out. If we go back on the other videos and look at how we did the wave shape, and we're just using one single TL074 quad operational amplifier, which looks like so. If you're unsure of the pin outs, make sure you try and have a look at the data sheets. There's plenty of diagrams online. If you just have a look straight through Google and look through the images for the operational amplifier pin outs. Now there's 2 ways we can do this. I'm going to quickly run you through the first way we can do this. So now we have all our op amps out. We need to find out which one of these outputs is going to be the lowest, and what we need to do is make sure every other wave shape matches up in amplitude. So say for instance 9 times out of 10, could be less, 8 times, our triangle wave will be the quietest wave shape out. So we'll find that amplitude testing through a scope or use your ears, and what we'll do is we'll put in a resistor, which is say our R1. We may skip out R2 and R3 to compensate and block some of that current stroke voltage and volume and amplitude. So we'll have all these basically be at exactly the same or near enough roughly the same amplitude. And this part here, these here are our on-off switches, which we can have an on-off switch like this. This is an on-off, on-off. We can have something like this, or we can have maybe something like this. This is just something I salvaged, just a sort of stereo on-off selector switch. It doesn't have to be an on-off switch. It can be any type of switch. It's just a one-way, one-throw switch. And what we have here is our potentiometers. This arrow here, if we look on the potentiometer, would be the wiper bit, which is the variable bit, so where it slides across and varies the resistance, hence varying the volume. It doesn't matter which way around you can do this, but always make sure, well, my rule is always input into the middle, and when we output out from one of the sides, so we input in the middle, output from one of the sides, and take 1 to ground, or our 0 volts if we're using our, it will be ground stroke 0 volts, same thing. So the reason why we take it to ground is, on one side, is when I first started this project, I couldn't work out why I couldn't get my sound to completely shut off. So the reason why we put the 0 volts here, so it goes to earth, so it completely kills the volume. If you like, we can actually completely eliminate this. We can go straight through from the potentiometer and go straight through the resistor. The reason why I put in switches, it just, because there's so many controls on my synthesizer, it just makes it very easy to switch off each waveform as you need it and bring in the volumes as you need it. So yeah, so this is our option A. If we look here, we have our potentiometer, and that, another thing I need to mention about that, if possible, it's probably best to go for a type. This is a B type, if we can see that. Camera can't quite focus. That's a B type, which will give us a linear response. Now the human ear has an exponential response to volume change, hence we use these A type, which are the logarithmic potentiometers. Right, let's get this the right way around. Well, here we have option B, pretty much the same thing. Now what we can do here is use one of these. Now one of these is a multi-way. I think we can go up to about 12 different positions of multi-way rotary switch. This is our switching position, so we bring our outputs to a common output, to 3 different outputs, and we'll have cables like so. We'll have 3 cables coming off that for each one of our waveforms, and one in the middle is going to be our output cable. So ignore this yellow cable. So we have 3 cables coming off to each of our waveforms, and this will be our output cable. So when we turn that rotary switch, we will select a waveform one at a time, like most common standard synthesizers use, as opposed to having all waveforms selectable at the same time. So if we have a look here, again, same quad op amp used, same outputs, but just a different option of selecting our waveforms. And we'll again send this all out to our VCF input. Nice and simple. Right, catch you guys in the next tutorial. Thank you for watching.